Friends, welcome again into my YouTube channel and into yet another session of Maths with Mukesh Raj. And without wasting time, let us start with the today's topic of trigonometric ratios of particular angles. Now, today we are going to find out and see how we can find out the angular values of particular angles using the trigonometric ratios. Friends, as we know, as you can see on the screen, that today I'm going to start with the first angle, that is specific angle or particular angle, that is 45 degree. This 45 degree, whenever we talk about this 45-degree angle, that means that into the triangle ABC, where the right angle is at angle B, then in this case, let us assume that this angle A is represented as to be 45 degree. Now, following the angle sum property of a triangle, the opposite angle that will be at angle C automatically becomes 45 degree in nature. Now, this nature of the particular angle which is being displayed on the screen makes it is very clear that this angle, this right angle triangle ABC, is an isosceles triangle. And no matter whichever angle is considered for the calculation of the trigonometric ratios, it does not make any difference into it. So moving ahead, proceeding with the solution, in order to find out the trigonometric ratios for the angle 45 degree into a right angle triangle ABC, let us assume that the side which are equal to each other, that is the base, or we can call, if I am going to find out the value with respect to angle A, then the base or the adjacent of angle A will be, let us assume that it's being assumed to be A units in length, and into this similar kind of adaptation, since it is an isosceles triangle, then the side BC, which is opposite to that of angle A, measured as 45 degree, then this also is assumed to be, let us assume it to be again A units. Now in this connection, only one of the lengths of this triangle, that is AC, which is again the hypotenuse of the triangle, is left alone, or it is supposed to be calculated. So let us calculate it without wasting time. And friends, once again, I would like to request all my dear young friends that if you have not yet subscribed my channel, please do it, because that adds and that motivates me to create new and challenging videos so that you could score better into your board exams. And if you find this video to be valuable for you or adds anything to your studies, then please do not forget to share it. You can even subscribe my channel with multiple devices. Now, let us calculate the hypotenuse of this triangle ABC, that is AC. So, as per the Pythagoras theorem, we can write AC square is equal to AB square plus BC square. And moving ahead with the calculations, A square plus A square. Now, this will give us the value which is said to be twice A square. Now, if I need to calculate the value of AC, this is supposed to be under root twice A square, which will give you a value under root 2A. And moving ahead, I will note down the value of this as under root 2A. Again, units will be applied. So I will write here unit. Now, from here, since I'm using this angle A as the reference angle for which I'm going to calculate the other trigonometric ratios, like suppose if I need to calculate the trigonometric ratios of sine A, which is 45, and then all the other cos 45, tan 45, cot 45, sec 45, and then finally the cosec 45. So in order to get all these trigonometric ratios, the values of all the trigonometric ratios, we can use, okay, we can use this as reference. And here, from here, let us, in addition to this, we have to be finding out these things like which is the adjacent side, which is the opposite side, adjacent side, opposite side, opposite. So here adjacent is the length AB and opposite is the length BC. AB is the adjacent. See, this is the AB is the adjacent, and BC is the opposite. So BC is the opposite side. And obviously the third side remains as usual, that is hypotenuse. Hypotenuse, which is equal to AC, which we have just calculated as root 2 A units. Without wasting time, we know that AB is equal to A units, BC is equal to A units, and then AC is equal to under root 2 A units. With these values, let us move ahead and get the trigonometric ratios. For the first one, that is sine of A, sine 45. Sine 45 is equal to opposite by hypotenuse, which is equal to A upon A. That means AB upon AC. AB upon, sorry, AB upon BC. Again, hypotenuse is AC. So putting the values, it will give you A upon root 2 A, and the values of A will get cancelled, and we will be left with the value 1 upon root 2. So if we want to see the value of sine 45, it will be equal to 1 upon root 2. And likewise, we can calculate rest of the trigonometric ratios, the values of the rest of the trigonometric ratios. Now, what are these values? Let us see. Moving ahead with the calculation of cos 45. So the cos 45 value, cos 45 degree will be equal to adjacent. I'm writing it down in short form, that is adjacent by hypotenuse. Okay. Now adjacent is, see, I have written here adjacent as AB, AB upon AC, because hypotenuse is common for both the cos and the sine. That is why. So AB, we have taken it as A, and then what is the value of AC? It is under root 2 A. Again, this A will get cancelled out, and you will be left with the value 1 upon under root 2. So from here you can see that the cos 45 value is equal to that of the sine 45 value, and that is equal to the constant 1 upon root 2. Hope, dear friends, this much must be clear to you. Moving ahead with the other trigonometric ratio, obviously the tan. The next one is tan 45 degree. This tan 45 degree can be represented as either the symbolic representation in the form of sine 45. Okay, sorry, just give me a moment. Sine 45 upon cos 45, or it is also equated as opposite by adjacent. We can write like this, that is opposite by adjacent. Fine. So putting the values, 1 upon root 2 into root 2 . into root 2 upon 1. So this will give you value equal to 1. And this was the value that we have obtained while substituting the value of sine 45 and cos 45. We have just the values which we have just calculated on the previous screen. If I put the value of opposite by adjacent, so the value of opposite is a. I'm putting the value as opposite upon adjacent, which is equal to, opposite is again the value as a and adjacent is a, as this triangle for which we are trying to find out the value of the angular measurement of 45 degree. It is an isosceles triangle, so the two consecutive sides adjacent and opposite becomes equal, and as a result we will be getting a value equal to 1. Now from here you can see both of the places, by following either of the method, you will reach to the conclusion that you will get a value equal to 1. Again, now the derived trigonometric ratios, that is sec 45 degree, which is equal to 1 upon cos 45. And what was the value of cos? The cos value was 1 upon root 2, isn't it? So here the cos sec 45 will become root